Alright, I want to show you how to use Matlab to solve a system of n linear equations. In this particular example, we're going to be solving a circuit problem. So here I have a circuit that we've solved by nodal analysis. We're looking for the three node voltages, V1, V2, and V3. We have placed the three equations into a matrix form here, where we have a conductivity matrix G. We have the unknown voltage vector V, and then on the right we have a source vector, which is comprised of a 10 amp current source. And so to solve for the unknown voltage vector, we need to take the inverse of G, assuming it exists, and multiply the left side and the right side of this equality by G inverse. That will get rid of G on the left side and will allow us to solve for the voltage vector as being equal to G inverse times I. So we want to do that in Matlab. So if you open up Matlab, you will have something that looks something like this. You may have slightly different things that are displayed within your workspace. You can control that by clicking on the desktop drop-down menu and you see check boxes next to different items. So for instance, the current folder view can easily be turned off. You may not have that. What you want to make sure that you have turned on is the command window, and you have the editor turned on. Those are the two things you really want to have. So when you're typing or using Matlab and typing in commands, you can kind of use Matlab as a calculator and just define things at the command window. So I could say x is equal to 3, and that defines it. It also echoes it back. I could say y is equal to 5. If I put a semicolon, it suppresses the echo, and then we could go x times y, enter, and now it evaluates that. We could define a vector a equal to 1, 2, 3, and that is going to be a row vector. So I could do a vector b equal to, let's see, 1, 2, 2, 2, 2. And if I want that to be a column vector, I can transpose it. So putting the single quote there actually transposes it and makes it vertical. So now I can do a times b, and it gives me 12, because I multiplied a 1 by 3 times a 3 by 1. So anyway, that's how you can use it as just from the command window. If you're wondering, well, how many different variables have I defined, you can type in who. It lists all the variables. And if you type whose, then it lists not only all the variables, but it also lists the size of each and the class, like is it a double precision or is it a character, whatnot. So if you want to clear the memory, you just type clear. And now if I type whose, there's nothing there. It's deleted all of the memory. And that's memory that would store the variables, it would store any functions you defined, etc. Alright, we can also clear the command window by typing CLC. That kind of clears everything up. Now, most of the time you'll want to be actually writing a script, so it's just a text or an ASCII text document that you type in your commands and then you execute it at the end. And until you're done, until you execute it, Matlab is not trying to execute line by line. So I'll start off by a comment. That's a %sign. I'll just say example of solving 3 EQs, 3 unknowns. Okay, and what we need to do is specify the G matrix and the I vector, and then we can solve for V. So here I've pulled up the window so we can see our G matrix values. You enter the matrix by opening with square brackets, and we'll then specify the first row, so it's 7 over 20 space minus 5 minus 1/5 space minus 1/20th, and then we do semicolon to go to row 2, minus 1/5 space 3/10 space minus 1/10 semicolon to go to the third row, minus 1/20th minus 1/10, and lastly 7/20th, close brackets. And if I want to suppress the output when I execute this, I would put the semicolon. I actually want to see it, so I'm going to leave it unsuppressed. Then we want to specify the I vector, so it's I equal to, open brackets, say 0, 10, 0, but that's a that's a row vector. I want a column vector, so I need to transpose it. So put a comment after here and say single quote transposes the vector, or the matrix, I guess. Okay, so I could, let me put this down here, I could write the solution right now. I could say V is equal to G inverse times I. I could do that, but let's just go ahead and define G inverse, and I'll say that's G raised to the minus 1, and now we'll write V is equal to G inverse times I. Okay, we'll save this. I'll just say tutorial, toot. Should save it, and now we can execute it. We can click this play button or hit F5. And what it does, I can scroll up here. Here is where it we define G, and it echoed because I didn't have a semicolon up here. So it puts in, shows us the matrix. Then we define I. It did the transpose, so it's actually a column vector. Then we defined the inverse of G. Here's that. And lastly, V is 45.5, 72.7, 27.3 volts, and that's precisely what we'd found, or at least what the notes give as an answer. So that's how you use Matlab to solve for a system of linear equations.